Okay, in this video, I'm going to show you how to do the problems on the 5-question radical quiz that we took last week. So first question, let's read the directions first, right? We should always do that. Simplify each of the following. You must show work on all problems. So for the square root of 98, to simplify that, we're going to start with a factor tree. I'm going to take that 98, notice that it is divisible by 2 because it's even. 98 divided by 2 is 49. Just grab a calculator and do it. 49 is 7 times 7. We have the 98 can be written as 2 times 7 squared. That's what our factor tree does for us. We can write it as a product. Okay, square root undoes squares. So we're going to normally skip this step, but what we're doing is using a radical property that says the square root of a product is the product of the square roots. Square root of 2 is just the square root of 2, but the square root of 7 is 7. I should have written those in a different order. We've got square root of 2 times 7. We'll switch the order. We have 7 radical 2. In practice, we skip the 2 middle steps, and we go right to here. Square root undoes the square, so 7 comes out, 2 stays under. All right, square root of a fraction. We make that a radical applied to the numerator, radical applied to the denominator, and then we're going to take that 50, break it down as a product. We'll do 2 and 25. The 25 is 5 squared. So we'll have that for the 50. For the 81, I'm going to notice that it's 9 times 9. It's a perfect square. So the square root of 81 is going to be 9. So we got 2 times 5 squared from the square root of 25. Square root of 81 is 9 squared. In the numerator, 5 comes out because the square root of 25 is 5. In the denominator, 9 comes out, and we have our answer. 5 times the square root of 2 divided by 9. Problem number 3. We're going to take that 32. We're going to write it as 2 times 16. You can break it down completely into a product of primes, or you can look at the 16 as being 4 times 4. I'm just going to break it down as a product of primes. So 2 squared and another 2 squared. Pair them up. That's the idea. You need to pair them up because the square root undoes the square. So I'm going to write that as 2 squared. There's 2 of them. 2 more of them. And the 5th one. So pair them up. And then the x to the 7th, I'm going to look at that as being x squared, x squared, x squared. There's 2, 4, 6, 7. 2 comes out, 2 comes out, x comes out, x comes out, x comes out. The only 2 that don't come out are this 2 and that x. The square root undoes the square. So under that radical, we're still going to have a 2 and an x. 2 times 2 is 4. 3 x's make x to the 3rd power. And we have the square root of 2x as our last factor. And we're done. Little point that I want to make about this. That x squared, x squared, x squared is x to the 6th. And the square root of x to the 6th is x to the 3rd. That square root is the same as a 1/2 power, so it will take even exponents and chop them nicely into a whole number, like x to the 3rd. That's a useful thing to remember. Okay, example 4, or problem 4, sorry. Depending on the version you had, your quiz might look a little bit different. Some quizzes had a 7 here. The idea is exactly the same, so I'm going to do one of these. So, whoops. First thing I'm going to do, I'm going to take that 8 and I'm going to recognize that it's 4 times 2. So there's a perfect square factor in there. That 4 is a 2 squared. And the square root will undo the square. So the square root of 4 turns into a 2. I still have a 2 left underneath. 9 times 2 is 18, so I have 18 square root of 2. Minus 5 square root of 2. This is now like doing 18x minus 5x, and it becomes 13x. It's the same idea. 18 take away 5 is 13. I don't have x's, I have square roots of 2. So I have 13 square root of 2 for our answer. Okay, fifth problem. Again, there were two different versions of the quiz. So if you didn't have this version, you had one that had a 5 here. The idea is the same. Answer changes just a little bit. So square root of 3 doesn't simplify, square root of 2 doesn't simplify. So we're going to start by just distributing. We're going to multiply each of these pieces inside the parentheses by the square root of 3. It's like doing x times y minus z and making it x times y minus x times z, distributed property. So I'm going to begin by doing square root of 3 times the square root of 2. And then I'm going to multiply the square root of 3 times the 7 square root of 3. Okay, square root of 3 times the square root of 2 is the square root of 6, because we have a property of radicals that says the square root of a times the square root of b is the square root of ab. So the 2 and 3 multiply together. Okay. Over here, I'm going to switch the order a little bit. Remember, the square root of 3 times the square root of 3 is 3. Square root of 3 is the number that you have to multiply with itself to create 3. So that is going to be a 3 right there. Square root of 3 times the square root of 3 is 3. Think of it as the square root of 9, which is 3. Either way. Okay, so we have the square root of 6 minus 21, and we are finished. And those are the solutions to the radicals quiz that was given in class.